Well, this video is to go over the word problems in the handout. So I think that the Alex software doesn't really cover these types of problems in a good enough way that would allow students to be successful in taking the final. Because there's a couple of word problems like this on the final exam, and I don't think the software really adequately prepares you for that. I think it's got a nice introduction to word problems, but to really get a sense of how these types of word problems work, that's why I've made this handout and this video to go along with it. So, to start with, let's look at the filling a water tank problems. These are actually the second part of the handout. And let's go over the even. We'll look at the even problems as examples, and that'll leave the odd problems for you to complete. So, first let's look at the situation. In problem 2, let's see here, we're working with a 6,000 gallon water tank. And it's getting filled up from 2 different spigots or hoses. Okay, one of them is running at 300 gallons of water per hour, and the other is filling at 220 gallons per hour. Okay. Now, what we want to know is how long is each of these going to be running to fill up the 6,000 gallon tank. Now, the key information here is that the sum of the running times for both spigots, so the total running time is 25 hours. Okay, so that's the information that's in the problem. And generally, in working with a word problem, I always recommend the first step, well, I made my first step to draw a little picture and kind of write down the information. But after that, what we want to do is assign variables. Okay? So we'll say that x is the number of hours that the 300 gallons per hour spigot was running, and then y is the hours for the 220 gallons per hour spigot. Okay, so once we get that set up, then this is a key fact, is that x plus y has to add up to be 25 hours, right? If x is 5 hours, y has to be 20, right? If x is 10 hours, y has to be 15, and so on. All right, so I'll come back and talk about this in just a minute, because there's a slightly different way to approach this type of problem. There's nothing wrong with either approach. They're both equally correct. All right, so now we've got the fact that x and y have to add up to be 25 hours. Now we want to look at the water that's coming out, right? However long this spigot is running, it's going to put 300 gallons for every hour that it runs. So 300 gallons in 1 hour, 600 in 2 hours, and so on. All right, so we're going to say 300 times x plus 220 times y should fill the tank and give us 6,000 gallons. Okay, so the combination of this piece of information and this piece of information is what's going to allow us to solve the problem. All right, and the approach to do this is to isolate one of these variables. I'll isolate the y by moving the x to the other side. And then take this expression for the y variable and replace y with that. Because what that's going to do is that's going to give us an equation with just a single variable. Okay? So now what we want to do is go through this algebra, and then we'll be able to solve for x. So let's see here. This will be 300x, 220 times 25, I think that's 5,500, yeah. 5,500 minus 220x equals 6,000, right? So we just had to distribute that 220 into the parentheses there. So now, let's see, I'll combine the like terms here. 300x minus 220x leaves us with 80x. And then let's move the 5,500 over to the other side. And this will give us 500. And then we want to do 500 divided by 80. And so that should be 6.25 hours. And you can just leave it like that. If you wanted to do it in minutes, right, this is 6 1/4 hours, which is 6 hours and 15 minutes. You can just leave it as 6.25. And then we want to go over here and find out, well, if x is 6.25, then what's y? And that, I believe, is 18.75 equals y. So there's our answers. The x one, the 300 gallons per hour, has to run for 6 1/4 hours. The y, the 220 gallons, has to run for 18.75 hours. And if you take these two numbers and you go 6.25 times 300 plus 18.75 times 220, that should give us the 6,000 gallons. Okay, so we've answered the question. So a few minutes ago I was talking about this setup right here and using these two equations. Sometimes people have learned in a different class, or they just want to skip straight to this expression right here. If you know that x and y have to add up to 25 hours, then you can call one of them x, and the other one you can just call 25 minus x, and then you can go straight to this step right here. It saves a couple of steps in the problem. If you want to do that, fine, there's nothing wrong with it. If you prefer to set it up with the two equations so you can see everything that's happening, nothing wrong with that either. Okay, so that's problem 2. Let's see here. Let's erase some of this to get us set up for problem 4. Those are going to change. Okay, so problem 4, we have a tank that is 5,850 gallons. 5,850 gallons. One spigot is 150 gallons per hour, and the other one is 80 gallons per hour. And the total running time for both of those is 60 hours. Okay, so now we'll have x be the 150 gallon spigot, and y will be the 80 gallon spigot. And then again, we know that x plus y has to add up to give us 60 hours. Okay, then the other piece of information is going to be that 150 times x plus 80 times y has to fill the tank and give us 5,850 gallons. So 150x plus 80y equals 5,850. Okay, so now it's the same process. We're going to isolate a variable here. We'll get the y by itself and call it 60 minus x, and then we'll replace this piece right here with 60 minus x. And then we'll have 150x here. Okay, so now we need to distribute this 80 inside the parentheses. That'll be 4,800 minus 80x equals 5,850. And then again, we've got the common, the like terms here. 150x minus 80x is 70x. And then we'll move this 4,800 over to the other side. And so this will be 1,050. And then we'll divide on both sides by 70. And I think this comes out to be 15. Let's see, 1,050 divided by 70. Yeah, x is going to be 15 hours. And so if x is 15 hours, then y should be 45 hours. And again, you can check this. You can go 45 times 80 plus 15 times 150, and we should get the 5,850 gallons total. Okay, so that's problem 4. And then we'll look at one more of these, problem 6. Let's see here. So these will change. Okay, so problem 6. Let's see, in this one, the water tank is 2,500 gallons, and the 2 spigots are 75 gallons per hour, and the other one is 100 gallons per hour. So we'll make X the 75 gallons per hour, we'll make Y the 100 gallons per hour. And the sum of the running times, the total running times for those spigots is 30 hours. Okay. All right, so again, we know that X plus Y has to add up to give us 30 hours. And then we know that 75 times X plus 100 times Y should fill the tank and give us 2,500 gallons. Okay, so we're going to do the same thing here. Isolate the Y so that we can substitute in for it over here. So this will be 75X, and then 100 times 30 minus X equals 2,500. And now we want to distribute that 100 into the parentheses. So 75X, 100 times 30 will be 3,000, minus 100X equals 2,500. So here, when we combine our like terms, 75X minus 100X is going to be a negative number, negative 25X. And that's okay, because when we move this 3,000 over to the other side, we're also going to get a negative number over here, okay? So what is that going to be here? Negative 500. And then when we divide on both sides by negative 25, X should be positive 20 hours. So it doesn't matter that we got negative numbers here because our answer was a positive number. Okay? Now if you're solving a problem for how long something's going to take and you get a negative answer, there may be something wrong in your problem. It may be that that negative sign is telling you something about the problem, but it may be that there's a mistake somewhere along the way. Okay? So if X is 20 hours, then Y should be 10 hours. And again, we can check the problem. If we do 10 times 100 and 20 times 75, we should end up with 2,500 gallons. Okay, so that's it for the water tank problems. Now let's look at the mixture problems that were on the front page of this word problem handout. And these work a little bit differently, but they do have some similar aspects to them. So let's take a look at these here. We'll start with problem 2. It said a bake shop has cookies worth $2.70 per pound, and then some other cookies that are worth $4.50 per pound. And we want to mix these together, okay, so that we get 120 pounds of cookies that cost $3.75 a pound. Okay. All right. Well, if you look at the situation here, this cost is closer to the more expensive cookies. And so that says that we should have more of the more expensive cookies and fewer of the $2.70 cookies. Okay? If you split this right down the middle and had 60 pounds of each, then the price would be exactly the average of these two prices. Okay? So this one is a little bit different. And so this cost says that we're probably going to end up with more of the more expensive cookies. All right. So that's just kind of a, just a kind of informal way of thinking about what our answer is going to look like, or if we get the answer, does that answer seem correct? All right, so let's assign our variables just like we did in the other problem. We'll say let x be the number of pounds of the $2.70 cookies, and then y will be the number of pounds of the $4.50 cookies. And then we know that x plus y has to add up to be 120 pounds. Okay? And again, like in those other problems, if you just want to call this 120 minus x, that's fine, because we're going to end up there anyway. All right. The next step is to look at the prices for the cookies. So if we have x pounds of these cookies, and they cost $2.70 per pound, that means the total value of those cookies is going to be $2.70 times the number of pounds, which is x. Same thing here. We've got these cookies, they cost $4.50 per pound. We've got y pounds of them, and this should add up and give us the cost, which is $3.75 a pound times 120 pounds. All right. So there's the two equations that are going to allow us to solve this problem. Over here we want to do 375 times 120. That'll be 450. And then, let's see here. I'll go ahead and just write this all out again. Now we need to substitute for one of these variables. Let's see. Been substituting for y the whole time. It doesn't really matter which one you substitute for. Here, I'll substitute in for x. And so we're going to say that in place of the x, I'll put 120 minus y. And now we can solve for the y variable. Let's see. So we have to distribute that $2.70 inside there. So we got to do 120 times 270. That's 324 minus 270 times y plus 450y equals 450. Okay, so again, we've got our like terms here. 450 minus 270, 1.80 y. And then we'll move the 324 over to the other side. That should give us, let's see here, 126. And then if we do 126 divided by 1.80, we get y is going to be 70 pounds. 70 pounds of the more expensive cookies, and then over here, x is going to be 50 pounds of the less expensive cookies. Okay? And that's kind of what we said at the beginning. Remember, this cost is closer to the more expensive cost, which says that there must be more of the more expensive cookies in that mixture. Okay, so this was problem 2 in those mixture problems. Let's look at another example now. Problem 10, I think, is a good example. And then we'll look at a couple other examples, too, that are a little bit different. Okay, let's see here. Okay, problem 10. A grocer mixed 2 kinds of nuts. Brazil nuts costing $5.80 per kilogram. So let's see here. Brazil nuts, $5.80 per kilogram. And then what? Walnuts that cost $5 per kilo. $5 per kilogram. How many kilos of each kind of nut should be included in a 40 kilogram mixture? So if we're going to have 40 kilograms of these nuts mixed together, and they're going to cost $5.50 per kilo. Okay. Well, that says that we should have more Brazil nuts, right? Because this cost is closer to the cost of the Brazil nuts. So that's just, like I said, that's just kind of an informal thing to think about as you're starting the problem or after you finish it. Or you don't have to do it at all if you don't want to. All right, let's see here. So, next thing we need to do, assign the variables, right? We want to know how many kilograms of each kind are we going to need. So we'll say X is the number of kilograms of walnuts, and Y is the number of kilograms of Brazil nuts. And now we know that X plus Y has to add up to be 40. And also, if we want this cost to work out, then the cost of the nuts that go into the mixture should equal the cost of the mixture, right? So for the walnuts, it's going to be $5 times X. And for the Brazil nuts, $5.80 times Y. And that should equal the $5.50 times the 40 kilograms of the total mixture. Okay. So now we have to do 550 times the 40 kilograms should give us a total cost of $220. And let's see here. Now we want to substitute out one of these variables. And again, it doesn't matter which one. Let's see. I'll move the X over here, and then we'll replace that Y with this 40 minus X. So this will be 5X 580 times 40 minus X, and that should all be equal to 220. And let's see, now we have to distribute 580 times 40, 232, and then minus 580X equals 220. Okay, so again, when we do these like terms here, 5x minus 5.80x, we're going to end up here with negative 0.80x, and that's okay because when we subtract that 232 over to the other side, we're going to end up with negative 12, and then when we go ahead and do the division here, divide on both sides by negative 0.80, x is going to be 15 kilograms for the walnuts. And then that means that Y should be 25 kilograms for the Brazil nuts. And that's what we were saying at the beginning, remember? Because this price is closer to the price of the Brazil nuts, that means that there's more Brazil nuts in the mixture. Let's see, did I answer the question that was on the problem? How many kilos of each kind of nut should be included? Okay, good. So we did. All right, so that's problem 10. Now let's look at a couple more examples that are a little bit different. It's essentially the same scenario, but the question is set up a little bit differently. So let's take a look at those. All right, problem 4 is a good example. Let's see, we've got some spices here. We've got one spice that sells for $4.20 per gram. And then the other one is getting mixed with 30 grams of a spice that is worth $3.60. So $3.60 per gram. And we want to produce a mixture that's going to sell for $4 per gram. Okay? So this is a little bit different because notice that we don't have the total number of grams in the mixture, but we do have the information that we're going to have 30 grams of this spice that costs $3.60 a gram. So, how do we set this up? let's see here. Let's let X equal the number of grams of the spice that costs $4.20 a gram. Okay? Well, that tells us that if we're mixing X grams together with the 30 grams, the total number of grams in the final mixture is going to be X plus 30, right? If this were 10, this would be 40. If this is 20, this would be 50. So this is going to be X plus 30. So we actually aren't really going to have two separate equations in this problem. We've really just got the one variable X, okay? And so then our equation is going to say, well, if we take that $4.20 times X grams, and we add it to the $3.60 times 30 grams, then that should equal the $4 times X plus 30 grams. Okay, so let's see here. Let's do the algebra. We need to do 3.60 times 30. What is that going to be? 108? 3.6 times 30? 108. Over on the other side, we'll get 4x plus 120. Right? 30 times 4 should give us 120. So now we'll move so now we don't have like terms on the same side. I've got to move these x's over here. So that'll be 0.20x plus 108 equals 120. And then we'll move the 108 over to this side. So 0.20x equals 12, right? And so then we do 12 divided by 0.2, x should be 60. Okay, so if we get 60 grams at $4.20 a gram, so 60 times 4.20, add that to the 30 grams times 3.60, that says that the total cost should be $360. All right, let's see here. 60 times 420 plus 30 times 360 gives us a total cost of $360. We've got a total of 90 grams, so if we divide that by 90, that comes out to be $4 per gram. That's what we want. Okay. So you can see how problem 4 is a little bit different from those first two examples that we looked at. Okay? All right. Let's look at one more of these. Problem 12 is a good example here. All right. So, problem 12, got 100 kilograms of a nut mixture that they want to sell for $4 per kilogram. So that's the total mixture. We've got 100 kilograms and we want to sell it for $4 per kilogram. He adds nuts that sell for $3.20 per kilogram. Oh. So now we're going to take this mixture and we're going to add some nuts that cost $3.20 per kilogram. If he wants to sell the new mixture for $3.40 per kilogram, so our new mixture we want to sell for $3.40 per kilogram, how many kilos of these cheaper nuts should be added? So that's our variable. Okay, this is going to be our x. X equals the number of kilograms of these nuts at $3.20 per kilo have to be added to this existing mixture so that we come out with a final cost of $3.40 per kilo. Okay, so now the total mixture is going to have 100 kilograms of the original mixture, X kilograms of these other nuts. So this is going to have 100 plus X kilograms of nuts all together. Okay. And you can see how this one is more like number 4 than it is like those first 2 examples that we saw. Okay, because again, we really just have the single variable in this case. So what we're saying then is we've got 100 kilograms of this mixture at $4 per kilo, and we're going to add in X kilograms at $3.20 per kilo. And then we're going to want to sell this total mixture, 100 plus X kilograms. We want to sell it for $3.40 per kilo. So there's our equation for this scenario. All right, so let's go ahead and do a little calculating here. 340 times 100 should be 340 and 3.40x. Okay. So there's the setup. Let's move this over to here. 3 minus 3.20 on both sides. So that'll be 400, 340 plus 0.20x. So then subtract the 340 on both sides. That'll be 60. And then, so now we just want to divide on both sides by 0.20. Let's see here. So what do we come out with? Is that going to be 360 divided by 0.20? Yeah. X is going to be 300 kilograms. So that's quite a lot. But I guess, I mean, if you want to bring the price down, you're going to have to add in a lot of these less expensive nuts. So what is that saying? That's saying our final mixture here is going to be 400 kilograms at $3.40 a kilogram. So that's 400 times 3.40. So that's a total cost of $1,360. I've answered the question already. The answer to the question is 300 kilograms. I'm checking out that answer. You don't have to do that yourself. You've got an answer key. But you can go back and double check that this is correct. Okay. So let's see here. So this total cost is $1,360. Down here, 100 kilograms at $4 a kilo, that's going to be $400. And then we've got these 300 kilos at $3.20. So let's see, 400 plus 300 times $3.20, also $1,360. Okay, so we know that this calculation works out correctly. All right, so hopefully you found this helpful. Like I said, on the final exam, you will see one of each of these problems. Okay, there'll be a mixture problem, there'll be one of those water tank problems, and so I just wanted to give you some good examples of that type of problem. And if you have any questions, please let me know. Be happy to email or talk with you about this.